This is a deadly aircraft. Proved itself over and over again in Korea, 1950 to some idea of the power of the thing. It fired 6.51 machine guns at the enemy, and that in itself must have been devastating. I'd like you to look at it, and then I'm going to pass it over to Victor, and he's going to give you more of the intricate details. Incidentally, this was the North American Sabre Mark 6. Right? All right, Victor, this is one hell of an aircraft, isn't it?
Yeah, and I was fortunate enough back in the days when they were producing these in the early 50s to go through the assembly plant and see how they were put together, and they're built extremely ruggedly. You notice, first of all, that while the earlier aircraft we looked at had rivet heads sticking up all over the place, you won't see any rivet heads on this one. By now we're moving into the jet age where streamlining is extremely important, and all the rivet heads are flush. They're countersunk. Even the screw heads on the removable panels are countersunk the same way. So the surface of the beast is extremely smooth. You mentioned the 6 50 caliber machine guns, 3 on each side. You see the slots through which the bullets passed, leaving the aircraft. And you say, well, why didn't they put them out in the wings or someplace like that, as they did on earlier aircraft? And the answer is they wanted lots of room for the large belts of machine gun bullets. And these were bigger than the earlier machine guns. The earlier ones were 30s, these were 50s or 51s. And they take up a lot of room down below the pilot's position on the aircraft itself. If you look at the wing, you'll see it's very, very thin. And this again is a factor in its speed. So they put them in the fuselage because there they had room to install them properly and aim them properly, and had lots of room for the belts of cartridges to keep them firing.
But for all that, their firing capacity 12 to 14 seconds.
Oh yeah, not very long.
No, and their rate of fire would probably be at the most 3 seconds at a burst.
Oh yeah, yeah. I think 2 or 3 seconds and the target wouldn't be there anymore. No, it would have just disintegrated. Mm-hmm. Yeah, no matter what it was.
Let me draw attention, for the sake of the viewer, some of the finer points of this. This extended their range considerably because there's one on each side.
That's right.
And they're pods that contain, I imagine they contain somewhere in a region between 150 and 200 gallons.
Something of that order, I'm sure.
Yeah.
And that was probably a great boost on top of what limited space there was in the wing for fuel.
Now these actually controlled the air. The MiG fighters had no chance against them.
This was a very versatile airplane. It had an enormously rapid rate of climb. It was fully aerobatic. Any maneuver you can think of that an airplane can do, it could do. And it had this tremendous firepower. And with these tanks, it had range enough to go a long way from base and carry on whatever it had to do and get back safely.
Now we see the pilot's position. He's got an all-round view.
Oh, completely.
And he has the same kind of mirror that the Spitfire had.
Yeah.
So he could see anything that was coming from behind.
Right, and I think if you look at the back of his seat there, I think there was a sheet of armor plate up the back to protect him from being shot from behind.
I wonder why it took them so long to think of a simple thing like this, but saved so many pilots' lives, you know?
Well, some of the World War II bombers had armor-plated seat backs.
Only towards the end.
Yeah.
Only towards the end.
The Mitchell is the one that comes to my mind because I was familiar with them, and I know they had it.
Well, I flew those in North Africa, where I was supporting Montgomery against the tanks.
Right.
And the Mitchell was a fine aircraft. And as you say, the armor plating saved many a pilot.
Oh, yes.
Yes.
Now, this aircraft had several interesting features that you can't see too well from here. First of all, it had retractable undercarriage, which went up flush into the wing and was completely covered in the up position so that there was minimum drag there. Being a jet aircraft, of course, it had an intake here at the front, although the engine itself is back behind the pilot. This is just an intake structure here. And by then they were getting to have radar, and here you have a little radar unit here at the front.
Yes, yes.
Farther back along the side of the aircraft, there were dive brakes that swung out on hydraulic controls to control the speed of descent, so that if the aircraft went into a steep dive, it didn't necessarily have to go terribly fast. These dive brakes were part of the evasive tactics. You could start down and then open the dive brakes and slow down very much, and if you had somebody behind you who didn't have dive brakes, he'd go past you. Then you got your shot at him.
The speeds were far superior to World War II aircraft.
Yeah, not a lot. These were not supersonic. This first generation of jet aircraft.
Around 600.
Yeah, something like that, as against 450 for your best propeller-driven aircraft.
Yes,
This kind of aircraft embodied all the tricks they'd learned from propeller aircraft and just moved the speed up a couple of hundred miles an hour.
just a couple of hundred.
Well, it sounds easy, you know, but it really went far deeper than that. If you looked at the inner structure of the wings on this aircraft, as I was privileged to do in the assembly line when I saw it, the inner structure is tremendously strong. In fact, some of the main spar structures are milled out of very heavy stock rather than being made out of pieces riveted or bolted together. They're milled out of great beams of heavy material, not heavy in weight but thick, and then thinned down to lighten the weight by cutting away the surplus material. I had never seen milling on that scale done before, where they'd start with an aluminum or magnesium or an alloy bar.
That's for strength, is it?
Yeah, you know, a bar maybe that by that, and then you mill it down and cut curves out of it and so on, and you get it to the exact shape you want for the spar with the strength exactly the way you want it, but no joints in it. It's all one piece, made out of a single chunk of metal. This was a matter of strength compared to very light weight. It was a very tricky aircraft to build, and Canadair had the facilities, one of the few places to do that. This again was designed by the North American company, the same people that built the Harvard and the Mitchell and so many other famous airplanes. The Mustang was their propeller fighter, again the same company. They knew how to build good airplanes, and they did.
Well, they cut this one away to let people see exactly the intricacies of the workings inside.
Yeah.
Here you have 1, 2, 3 machine guns.
Yeah.
They're all synchronized. They come out through the 3 vents, and I imagine the popular distance for striking would be 600 feet, Victor?
I don't know exactly, but that would be my guess.
I imagine that's where it is.
Yeah, they would converge ahead of the aircraft at some point.
You have the belts of ammunition, the .5 vicious shells.
You know, they're big.
Yeah.
Anything you hit with a shell that big isn't there afterward.
Well, I mean, when you see, you start from here, look.
Yeah.
It goes right through to there. That's one impressive piece of armament.
Yeah.
When you get 3 on each side, all firing at the same time, I imagine...
You'd feel the shock when you pull the trigger.
Indeed.
And you wouldn't pull the trigger, you'd push it. It would be on the control column, and it would be a button. But you'd sure feel the bump when you fired it.
Yes.
Give me an idea of what kind of a hole would it make if this one was shooting at a plane identical to it? One of those bullets hit?
Well, a single
bullet would make a hole about that big.
Yeah.
Okay? But if you had a concentration of 6 hitting, look at a hole as big as my head. The hole would be as big as my head. It would literally tear a section right off the aircraft, and that would be it. In fact, I've actually seen the effects of an FW-190 when it strikes an engine cowling from the rear as he's diving. And it would take a huge Lancaster engine right up his mountains. That's the effect it has, you know.
Yeah.
The combination of .5 machine guns and the 20-millimeter cannon, devastating, absolutely devastating.
Yeah.
And I imagine this one was as lethal as any aircraft that flew in Korea.
Oh, I'm sure it was.
They made their name. Oh,
Yeah.
sure.
Yeah,
Made their
it
name
definitely
in
was.
Korea.
Now, it had all sorts of tricky things. It had a controllable leading edge
Yes.
that could tip down, as well as its flaps on the trailing edge. And this made it very easy landing and easy takeoff. It could work from relatively small airstrips.
Yes.
And with these dive brakes, which could control its speed in the air, it could change its speed very rapidly, which in a dogfight was a very important part of the game.
Now, one point we must make before we leave this wonderful aircraft, and I'm sure you can explain this. I've got a fair idea what it is. Here you have a list of names.
Yeah, well, these were the pilots that were a part of the team that put on aerobatic shows.
Ah, I get it.
This, you notice it's a gold-colored aircraft.
Yes, yes.
This was a part of the Golden Hawk aerobatic team,
see, yeah.
and they were the forerunners of the groups like the Snowbirds and so on that operate nowadays. The Air Force has always had a display group who could put on public displays to show what the aircraft could do for Air Force Day celebrations and that sort of thing.
I see.
And this was one of the earlier teams. And when the team switched off this kind of aircraft, this aircraft became available to be preserved as a memento.
Yes,
Of
it's
it.
a
It's-
wonderful memento of the firepower that was produced in North America. On this side, I was asking Victor, because this pod, which carries a considerable amount of fuel, has got these fins on it. And when I asked Victor, he came up with a very interesting explanation. Will you tell them what that's for?
Well, that much fuel would weigh a lot, and that would put an added strain on the wing. And so when the airplane is in the air and flying, these fins on the pod act to lift the weight of the pod itself, so that in fact the effect on the wing of the airplane is neutralized. So the wing tank essentially flies itself.
I see. So
So the weight is supported at flying speed largely by these fins.
And whatever maneuver they make, this fin will, in effect, if we like to put it this way, would not be there, because of the upflow on the foils would take the weight.
Yeah, so that the weight of that tank doesn't affect the performance of the aircraft to any great extent, which is important if you want to keep the full fighter performance,
Yes.
even when you have tanks on.
Now we have a cutaway of the engine, the propulsion unit that
That's right.
drove this thing to the speeds it could do, and maneuverability, of course, because it could.
Right.
Yeah. Would you just try and describe
Well,
that?
if you look up at the front part of it here, you can see some blue-colored sets of fans, one behind the other, like a bunch of windmills
Yes.
in a pipe. Okay, the air comes in at the nose, as we spoke before, and comes under the pilot, and finally up into this section here, where you have a series of fans with fixed dividers between them. And as the air moves back through these fans, it is compressed to a higher and higher pressure. And finally, back here, it's fed under high pressure into combustion chambers. And there's one cut open there, and you can see it's colored yellow and red. There the fuel is injected in, and the compressed air comes in around the side. The whole thing is ignited, and you've got a fire going. Now, there's a whole series of these in a ring, 4 or 5 of them. So at the backside of that, the air has been compressed initially, then it's heated by these flames, and it comes out this narrow jet against another set of very fine blades here. And this is the turbine. This is where you get the power that in turn drives the compressor.
I see.
And the surplus of this hot air that's going out goes past these turbine blades here and out through the tail of the aircraft, and that's what pushes the aircraft ahead.
And that's why at times you see flames coming.
Oh yeah, well, the flames that you see at the back are an addition where they inject extra fuel back at the back end for extraordinary power, what you call an afterburner. Normally your flames don't get much past this point where it's painted red.
Well,
But you think about a piston engine where the piston comes up and compresses the charge so that it explodes. Here you've got a rotary compressor, an axial flow compressor. The air is flowing from that end through along the axis of the compressor, through to here. So it's compressed even to a higher pressure than in a car engine. Then the fuel is injected and ignited, only this is continuous. It's not in pulses like a piston engine.
No.
Fuel injection and ignition are continuous, and the output is continuous. So you've got a continuous thrust that shoves the aircraft forward.
What about the fuel? Surely this is not the only fuel this aircraft
No,
has.
it has wing tanks as well. There's
Yes,
an opening there.
of course.
Yeah. Part of the fuel is carried in the wing and an additional amount underneath to give it much greater range.
Yeah.
The wing tanks don't need to be carried. If for short range, they would be left off because they do create a little bit of drag,
Yeah.
not very much. Now, the other thing that's of interest, this panel here, you notice this is a hinge bar, and
Yeah.
so is this.
Yeah.
Part of that's been removed, so you can see it. This panel can be forced out almost at right angles by a hydraulic cylinder, and that creates an enormous retarder effect on the forward motion of the aircraft. That's what you call an air brake. That can really slow the aircraft down, and in certain maneuvers, it's very important to be able to change speed quickly. You merely push the right control, and these doors, one on each side, swing out, and the aircraft slows down just as if you'd slammed on the brakes.
So that would reduce the length of the runway that you need.
Oh, you can use it for that, or you can use it to come down almost straight down at a controlled speed. Or if you're in a dogfight and there's a chap behind you and you don't want him behind you, if you slow down fast enough, he'll go past.
Oh, yes.
And then you get your shot.
Yes.
Yeah.
Yeah.
You know, it could be used all sorts of ways.
Yeah.
Now, if you go back here a little further, here is the tailpipe where the hot gases come out and go on back.
Yeah.
This is the outlet of the power plant. And you notice all the structures are metal, including the control surfaces,
Yeah.
and all the riveting is flush.
Yeah. All to reduce drag and give them the...
Yeah, that extra speed.
I notice the tail section will move according to the...
Yeah, the whole thing, yeah, it's what they call an active tail. An active...
active tail.
Yeah. Instead of having trim tabs at the back, as we saw on some aircraft, here you can alter the angle of the whole tail surface to trim the aircraft, depending on the load you're carrying and the maneuver you're trying to carry out. A lot of modern jet aircraft do that. You notice on the vertical stabilizer, you have a trim tab.
That's right.
It's only on the horizontal stabilizer that you get this active situation where you move the whole surface.
And the unusual high tail section.
Well, this is a pretty high-performance aircraft, and it takes a good-sized rudder to handle it in the kind of maneuvers it can do.
Yeah.
And so you've got a big surface there. Your horizontal stabilizer is pretty good size, too.
Yes.
And that's, again, characteristic of a high-performance aircraft.
That bears out what you were saying about this being part of the team for the Golden Horse.
Yeah,
And
yeah.
It's got it there.
Yeah, the Golden
Here.
Hawks, yeah, that's right. This was used after its military performance as a demonstration aircraft.
I imagine this aircraft was a welcome sight in the skies for the troops.
Oh, I'm sure it was.
Yes.
In its operational role, I'm sure it was.
Along with hundreds of recorded interviews, our group has been involved with the recovery of submerged aircraft from Norway, Belgium, Malta, England, and the Baltic Sea. Our Zoom show, airplanehunters.org, details these aircraft recoveries as we honor our veterans.
Hi everybody, Carl Casgard reporting to you from Bomber Command Museum of Canada in Nanton, Alberta, and along with my colleague and buddy Scott Knox at the Rebuild Shop in Arnprior, Ontario, where we're doing all the Halifax bomber restoration. Welcome. We want to give you an update, and we're going to try the split screen today, show you this little program on our great progress. We're in the last month of 2021 in December, and we've made good, steady progress.